Okay, so what I'm going to very quickly say is I don't feel as though you should be privileged. It's just me. I'm just the average everyday Kiwi, as it were. So don't be privileged. I'm more than happy to answer any question of anybody at any time. My aim here to be here this evening is to give you the opportunity to ask some questions about New Zealand as a whole, and the current situation in New Zealand and the building industry as generally. I'm going to talk about some issues which are beholding to the building industry and the construction industry globally, but I'll also talk about them in the Kiwi context. A quick sort of preview. AUT is one of the largest universities in New Zealand. New Zealand is a tiny place by comparison to India. The total population is about 5 million. We have about 12.5, 13 million cows, and we have about 37 million sheep. So as a population, we're relatively small. Big country, but a relatively small population. We have a fascinating mix of opportunities for students who are coming from different countries, and we have a very strong reputation in India. Personally, I've been going to India for many years now, and it's something I not only do, but I enjoy doing. I like to go to India, and I have some very good friends there, including Kush here, who's representing Estro New Zealand, or estro.co.nz. AUT is, as I say, the newest of the various institutions that we have. There are 8 universities in New Zealand. We have about 30,000 students, of which one of the largest areas within AUT is engineering construction. We're a very, very capable space. We have some excellent facilities, and I'm more than happy to talk about that. But I'm not going to sort of be too greedy of your time. I'm going to talk about the presentation that I've got lined up for you this evening, just now. Obviously, as Colonel Girish just alluded to, happy to have the conversation, happy to answer any questions you may have. But if we can just leave it to the end, and then I'll just hoover it up in terms of some of the Q&A. That's no problem whatsoever. So very quickly just now, I'm just going to switch over to the different shared screen, and hopefully you'll be able to see my presentation just now. And if somebody could just give me the thumbs up that they can see that okay.
It's all good.
Anybody?
Yes, all good.
Excellent. Right. Oh, we've got 2 people raising their hands. Audience participation, we like that. So, as I alluded to, my name's John Tukey. I'm from AUT University. If you're interested in any of my back catalogue of observations and thinking with regard to the building industry, I'd recommend you Google my name and have a look at some of the newspaper articles and various different radio and television presentations that I've given over the years. I'm easy to find, which makes me that sounds a bit dodgy, but you get the idea. Please just have a look at what I do, and if you have any specific questions, then please, by all means, come back to me after this presentation. What I'm going to talk about this evening, or for you this morning, is the future of construction IT, issues of design management and some procurement practice, and some of the problems and issues that need to be raised for the future. And some of the idea here is to get you guys collectively thinking about some of the wider issues. It's easy. The easiest thing in the world is for me or any other professor to talk about theory. What I'm going to talk about this evening is practice, and I'm going to talk about the issues that you guys collectively need to understand so that you can have a better handle on the future of the building industry. So, hopefully, if we can just go forward now. So, the best way of describing this is the good and the bad and the ugly of building information modeling. Now, the reason why I say all of this stuff is because historically we've been really, really bad at thinking through what the implications of technology are. Excuse me. So some of the classics are what's quoted in front of you now. From IBM in the 1940s, we have, I think there is a world market for maybe 5 computers. It talks about ENIAC here, which is equipped with 18,000 vacuum tubes, weighs only 30 tons, and computers in the future may only have 1,000 vacuum tubes and only weigh 1.5 tons. Could you imagine a computer that weighs 1.5 tons? I've traveled length and breadth of the country and talked with the best people. I can assure you that data processing is a fad. So said the head of Prentice Hall Books. But what is it good for, said an engineer at Advanced Computing Systems Division of IBM in 1968, talking about the microchip. And then ultimately, which is one of my personal favorites, this is red letter day to me, 640K ought to be enough for anybody. Excellent. So said Bill Gates. And the bottom line with all of this stuff is the fact that we're on an escalator and we're talking about what's referred to as Moore's Law, which is the tendency towards rapid escalation in technology. And we're dealing with it all the time. All I'd ask you to consider is everybody's sitting around a room now, to consider how many mobile phones that you've had over the years. How rapidly has their capability and technology increased? Back in 2008, we had the concept of a microchip being about the size of a grain of rice, which with 47 million transistors and so on. Only a few years later, we're talking about massive escalation in capabilities. If we look at 2005 versus 2014, same technology, same issue, which is a micro disk here. Going from 128 megabytes to 128 gigabytes. And this is all based on technical understanding and technical capability with regard to, again, what I refer to as Moore's Law. It's a well-known issue from the electrical industry, which is every year and a half, the capability of a computer doubles and the price stays the same. The reason for this is because the ability of us to create circuitry onto silicon wafers actually increases much more rapidly than you might consider. And the reason for this is the ability of, ironically enough, photography. And here's by hangs an interesting tale. The capability in photography generates an increased capability, or rather the capability of photography means that we can minimize or reduce the total scale of a very, very complex system circuitry onto a silicon wafer. It then gets created in physical form as a result of can I just ask anybody who's raising a hand at the moment, can you come back to me at the end of the presentation, please? Because just need to crack on with this. That ability to reduce photography to a negative size for the creation of a silicon chip means that you can create more transistor computers, which allows you to, ironically, reduce the size of or increase the capability of being able to reproduce a negative of a photograph, which allows you to be more capable in terms of the ability to reproduce a circuit diagram, which and basically what you have is a self-reinforcing cycle. This self-reinforcing cycle means that every year, every 18 months, the total number of switches that we can put onto a disk of silicon doubles, and the price stays the same because it's just as cheap to do it. Now, the bottom line is that we, as a society, are constantly, our capability is escalating rapidly towards the roof, and we are struggling as a society to keep on top of this. And if we see the total number of switches that we can stick onto a microchip, this gives you an indication of how far can we go. But you can see this is a logarithmic scale, and we have got in effect an exponential growth profile, going from 3x6 through Pentium 4 through to dual core, on, all the way up to where we are now, which is just absolutely crazy. The next step is going to be quantum computing. When that comes live, I don't know. But again, that's going to create another opportunity to escalate the capability of our technical solutions. And we can see it just in terms of scale as well. We go from, quote, small beginnings through to how we deal with the future. Now, this is going back to 1958. This is a design office, and the computer system basically fills this room. And as you can see, the interface is less than user-friendly. We have a typewriter, electronic typewriter, which is our interface, along with a TV screen and a whole bunch of reels and so on. But this is negligible compared to a capability. Everybody in who's currently on this line, the capability on their computer is literally multiple orders of magnitude greater than the technical capability and the computing capability that took the space shuttle into space or Saturn V to the moon. You know, we are talking about a level of technical advance which is just frightening at the moment. And you guys collectively as students and as engineers need to be on top of all this stuff. You know, we can see how things have escalated from the 1950s, from the first two-dimensional stuff through the 1960s and 70s, as we escalated the terms of complexity. And of course, we have a lagging indicator, which is actually the software systems that which are utilizing the technical capability in terms of hardware that we generate. And as every advance in hardware generates a subsequent advance in software, and hence and therefore it's a constant rolling exercise to be able to get to where we sit today. By the 1990s, we were talking about object-oriented CAD and the ability to be able to incorporate doors and windows of a particular scale and so on. And the effect of this technical advancement created a huge companion development in terms of how organization and management takes place in this type of environment. And this is actually where I personally sit in this, because obviously I've been training and educating engineering students with project management skills for many years. Question: how does this affect the way in which you do business? How does this affect the process of due diligence that you need to adopt in order to evaluate different competing tenders for a particular contract, for example? Excuse me. And you know, where is the internet taking us in terms of how we do business as construction managers? All of this type of issue, and that's before we even start talking about the issues of multiple operations in multiple locations and dealing with wider networks and the ability to be able to solve problems in a remote format with people who are no longer sitting in their office, they're sitting remotely. And even, you know, what we've seen over recent months, the advent of COVID, people talk extensively, and theorists talk extensively about the notion of disruptive technology. Well, I would contend to you that the impact of COVID on the global economy has been the ultimate iteration of disruptive technology. It wasn't done because somebody said, wouldn't it be a good idea if we disrupted things? It was a fact that the needs of the situation that we're dealing with require us to become more capable and more creative with the utilization of technology that we are utilizing as an industry. And you know, what we subsequently generate is a whole bunch of new solutions for a new normal. And you guys collectively as potential students, you need to start thinking about how this is going to change the way in which you do business. What I would say to every engineering student coming through any university in any country is that we tend to think in terms of what is the effect of, or rather, not what is the effect, but as an engineer, you tend to think in terms of, I need to learn about management. And you will learn about management in the form of one or maybe two papers that you study as an undergraduate in either maybe the third or the fourth year of your study. What does this? What do I need to know? And you'll learn the ideas of management on the basis of what was on the last examination. What boxes do I have to tick? How many points do I need to gain in this? What are the default settings in terms of actual solutions for the future? And it is literally that type of mentality. But you know, hereby hangs an interesting tale, ladies and gents, and that is very, very simple. The fact of the matter is that the situation that we have as an industry and as a society is evolving much more quickly universities can cope with. And we, consequently, we need to jack up our skill set to be able to cope with this. As we scroll forward into the 1990s, building information management in effect became the notion of CAD, or computer-aided design, with bells and whistles. It's all about technology driven. What's cool, what's design, and we were trying to figure out in the 1980s, 1990s, and early 2000s. So this is really cool. I wonder what I can use it for. But now we've gone beyond that. We're actually at a point where no longer is it just about being cool. It's literally about how can this technology actually help us. We were thinking at the time about what's possible, and the classic Jurassic Park quote is, everyone's trying to figure out what could be done. We wonder what should be done, or nobody figured out what should be done. We've gone beyond that even. Now we're sitting in a situation. It's not just using technology for the sake of it. It's a case of, oh my God, everybody's doing it in every location around the planet. How can we make best use of it? And what does the future hold? I don't know that, but I'm asking you to challenge your assumptions about what is normal. Okay, back to the sort of thinking of history here. So back in the early 2000s, we started thinking about building information modeling. Everything became fully integrated, and it was all about building all the various different computer-related solutions and the design aspects of how to bring our design together. We're all starting to be integrated, and all of the different elements of the various different softwares were started to come to a single common platform, which allowed us to be able to deal with every aspect of the construction process, from initiation through to ownership and the dealing with facilities management post construction. And where does this take us now? Well, we're actually in a position where our ability to design and our ability to be able to engineer and so on is actually at a point which is almost beyond credibility. What you're looking at just now is an example of what's called the Bird's Nest Stadium in Beijing, which was constructed for the 2008 Olympic Games. Back in the day when we could actually mix together as large groups and not worry about infection from COVID. This type of capability, just looking at this design, the complexity of this design to create this bird's nest, you're talking about formwork for construction, casting of concrete, which is rotating and transforming in three dimensions throughout the span of a construction process, irrespective of the complexity of dealing with the steel work and the rebar associated with this particular design. Massively complex stuff, and let's face it, things are changing much more quickly than we can get our heads around. This brings us to the modern day, or where we sit now, 2020, whatever you want to call it. We think in terms of building information modeling really now as we're at the pinnacle of where we need to sit. We can do more now than we've ever done before. But I will tell you, ladies and gents, you ain't seen nothing yet, because over the next 2 to 3 years, your understanding of what we can do will be undershooting. No question. We'll be overshooting. You will assume that we can do more. However, the rate of development that we're seeing at the moment means that in the next 10 years, you will not be able to even guess where we can get to, because you just don't know at the moment. Things are evolving more rapidly. Now, the good news is that building information modeling anticipates reduction of errors, requests for information, reduced rework, the ability to reduce risk on site through improved health and safety practice. You can enhance visualization so that people can understand what's taking place, and more broadly, the client can engage with the designs that you're creating with. But ultimately, it's about creating the holistic design that we can hang our hat on for the future. What does this mean in different countries? Interesting stuff. If you look at what's happening in the US at the moment, for many years there's been an increase in interest in building information modeling, and consequently We've seen an increasing proportion of all construction contracts for governmental purposes to be rendered in BIM. And actually, the only way in which you can get listed for a contract for a government job is to actually be capable of listing things in BIM. The idea being that we can reduce error, we can reduce costs associated with rework, and so on. And the rationale for this is because the complexity of governmental buildings, as an example, we have here a design, obviously in the US, everything is about either the military or the court system. Well, here in the US, this is an example for a design of courtroom. And there is a requirement to keep the judge and the jury, the defendant and the public all in separate streams. And consequently, your ability to be able to visualize constructs and visualize escape routes and visualize circulation routes around a building are massively increased in terms of their utility. And so if you want to get involved in the developing a governmental project in the US, you need to be able to provide this to government specifiers. And this is what's been happening in recent years. And you can see the thought process that takes place. You can see that increasingly over the period between 2009 and 2012, the number of people who are interested in and have the capability to be able to specify and use BIM, just because governmental specifications have required it, has mushroomed in capability. And now the vast majority of contractors in the US have this ability to be able to specify in building information management design systems. This means that it's omnipresent. Everywhere you look, US architects, engineers, and contractors are adopting similar protocols, similar ways of doing business. It's all pervasive. Everybody uses it. By contrast, only 37% of architects and 3% of contractors, 4% of structural engineers have adopted BIM in the UK in a similar time frame. And the reason being, because it wasn't being driven by government at that point. Everything was being driven by the old way of doing business, which is basically building information modeling is primarily an architect's tool or another designer's tool, which basically means that we as contractors don't need to know about it. All I'd say to you is that that's the old way of doing business. That's changing, and it's changing much more rapidly than you can possibly imagine. And we see it just in terms of the level of recognition of its use, just evolving very rapidly over a relatively short period of time, again, primarily in the US. How do we use it? Pretty much for everything. So increasingly, you'll see every aspect of a building's functionality being modeled through BIM in some way, shape, or form. This presents a further problem, because the question is, if we're specifiers, how do we define what it is that is necessary, essential for a BIM model, and also what is not? And basically, anything can be incorporated to a greater or lesser degree. Here we've got examples of the Miami Science Museum and its the principles of green, which it adopted in its creation and construction. Excuse me. The forward-looking mentality of the US at that period of time generally had a whole effect of flow-on effects of how other governments elsewhere did business. So if we look at what happened in the UK, all of a sudden in the UK, the notion of BIM was also raised, and consequently over the decade running from sort of 2009 through to 2016, not that it's a decade, but the bulk of a decade, all of a sudden the UK government started requiring this type of thinking to take place. And again, so it happened. But it's what's interesting in this instance is quite the difference in attitudes. If you recall the previous slides that I showed, the attitudes associated with the utilization of BIM at that point, which covered all aspects of architecture, construction, and engineering design development, everybody was interested. But if you look at what was happening in the UK at a similar time frame, the only people who are interested in BIM, building information modeling, and so on, and because of all sorts of historic reasons associated with how the construction industry was operating, you ended up seeing architects, architectural technologists being the primary indicators of interest in BIM, but nobody else was. And this is quite an interesting observation. The point being that different countries are differently interested in different issues related to building information modeling. And you end up with this sort of slightly different exemplar of how BIM was being introduced in the UK. 1 in 5 companies remain blissfully ignorant. They're just not interested, and so on. 40% of companies don't use even any kind of computer-aided design, and so on. And a lot even just consider 3D modeling as being what BIM is, and of course it is not. And again, a few other examples of relative interests and utilization. I don't want to bore you with the details there because it becomes a little bit samey. The bottom line is that BIM means different things in different countries. So the question is, how far can we go with all of this type of super sexy stuff? And let's face it, everybody is impressed by this type of schematic of how you can design a building associated with all the different subsystems that you can see here. It looks really cool, looks really sexy, but what does it really mean in real life? The key questions that we have to address as far as construction managers are concerned is, when are we going to invest? What are we going to invest in? How are we going to invest? What format are we going to invest in? What software? And what's next? And the rationale is very simple. I'm looking at some technology right here. I've got floppy disks running through to hard disks running from, excuse me, 5.25 inch disks running through to 3.25 inch disks. And these technologies, they were all state of the art at the time, and now they're ancient history. I'm looking at any of these things, and I'll know that anybody who's over the age of about 30, you will have seen, you probably have a few floppy disks, but chances are you won't have a computer that uses them. And this raises an interesting question. What format are we going to store all this stuff in? Even then, a lot of people today, I'm more than happy dealing with USB drives, but there's so many individuals who literally they've never seen a USB drive because everything gets stored in the cloud. Well, where does that live? Who owns that? How do I keep control of it if I'm commercially driven? How do I own the IP related to it if everybody gets access to it? And we've seen all sorts of interesting developments over history. Anybody who's been a fan of Star Trek over the years, all the technologies, whether it be the mobile phone or the touchscreen computer, that was all piloted back in the 1960s with Jim Kirk and the Starship Enterprise. And yet, even now, we're only scraping the sides of what we have the capability of being capable of being able to do in the future. Who are the futurologists who are driving this? And by the way, you look at your history, you look at what you've learned over the years of being an engineering student, for example, and think about what you've learned and what's missing from what you learned as a student and what exists today and you have access to. Even the issue of dealing with the notion of quick fix. Where the industry is going to jump in and deal with technologies and so on. The costs associated with getting people up to speed on different technologies, that's great, but what actually technology-wise are we going to be using for the future? Anybody who's older than 40, for example, might be aware of a concept known as the VHS recorder versus the Betamax recorder for recording videotape off of TV. Well, there's an interesting question, because neither of those systems exist, and very quickly VHS outpaced Betamax, and Betamax became redundant. But everything becomes redundant eventually. So the question is, what are we going to invest in? How are we going to invest in it? And what additional costs are going to be required to keep everything current? we tend to think in terms of the quick fix. As the video said, or as the photo says here, there was a spider. I panicked, but I think it's gone now, and I burned the house down to fix the problem. But actually, when we think about building information modeling, that's exactly what technologists are asking us to do. Throw everything else away, use this solution, because this solution is going to be successful. And again, everything is done on the fly because nobody at the moment knows where the future is going. All we can do is develop best practice principles and understand that what the hell's happening, rather than necessarily these are the technical solutions. And what I would say to you, ladies and gents, is quite literally, if you can get a handle on what those are the principles at stake here, you'll be successful in the future. You need to recognize the fact that building information modeling is actually going to increase some costs. It actually requires you to be more or you need to be much more invested in expending money and time and resource on developing complete solutions in terms of design. Because if you don't, you can't do it in BIM. You can't evolve things in BIM and then get the design afterwards. You have to get everything complete design-wise and then render it in BIM. Badly thought through BIM can substantially increase costs and coordination. Similarly with procurement. We need to redefine and reimagine our expectations. What actually is required, what's not. So the ability that we have to be able to sequence and engage contractors, subcontractors, and so on needs to be very carefully thought through. How is procurement going to be affected by all this type of behavior profile? What sort of effects are going to be had on the commercial aspects of managing contracts? And there's an awful lot of research needs to be considered, as well as legal liability. Just simple things like, for example, who owns the design? And by the way, if I give this design to the client to be able to use it for future elements of facilities management, for example, who owns the design at that stage? Bearing in mind it was my IP, if I'm the designer. So there's a huge element of this. Even stuff like education, for example, just being able to train people to be fully au fait with how the various different technologies operate and how they're developing in the future, and what is really required in order to be able to make these things happen. Again, I'm not presenting answers, I'm just presenting the questions that you need to ask yourself, so that when you select an appropriate program for the future to train yourself to be, fully compos mentors for developing construction for the 21st century, you're asking the right questions. So who owns the design? When do they own it? How do we transfer the information? And maybe in the future, for example, construction claims for delay or loss and damage is going to be driven by who has the best graphics and the best design solution in place that's represented in 3D by a BIM system, as opposed to the best legal arguments. These are the sorts of things that we need to start thinking, because there's stuff happening more rapidly than you and I can even contemplate in this short presentation. And that's before we even start thinking in terms of interoperability and all the other problems that we have. Even how information is stored. All I'd ask anybody who's over 30, if you've got CD-ROMs of data that you were storing 10 years ago, have you even got a computer that can read that? It's a simple question, and yet it's absolutely critical and absolutely obvious. Who's going to maintain it? Who's going to keep it up to date? Who owns the liability if somebody drops behind in terms of the maintenance of the design, and so on and so on and so on. So how are we going to, all of this, every aspect of what I've just said over the last sort of 10, 15 minutes or half an hour as we are now, these are going to be asking you questions, even trivial issues like who's going to upgrade the software, who owns the liability, who owns the IP, who owns the copyright, and so on and so on. Because this challenges education, it challenges you as a professional, and it challenges where you're going to take all this going forward. Where is it all going to go? Good question. some small and medium-sized companies are just going to give up and they'll just wait till something becomes ubiquitous and everybody uses it. However, looking forward, all I'd say is that we're in an evolving situation. We don't know yet where it's all going to go to. What you need as a professional in the industry is an attitude which says, bring it on, let's see how we can fix this, let's see how it can work, but we use the adopted principles. I've just run out, and basically that was a very rapid half-hour exercising in sort of tackling the critical problems as I see them for the future of how IT and how the building industry is going to operate, both in New Zealand and actually, ironically enough, in India, everywhere around the world over the next few years, because we are literally figuring it out as we're going along. Right. Thank you for your attention. I'm now going to stop sharing that. And I am more than happy to now take any questions that anybody has to offer. And I apologize for having rapidly hit through that, because normally I would sit and take Q&A from individuals in a classroom, and we'd probably make that even last for an hour and a half. So please, more questions. Any questions from you guys collectively?
We have two questions, Professor John, in the question answer box.